All right, how was that music, right? So, hello everyone, and welcome back to Cecilia's Tech Corner. I'm your host, Cecilia Rosatori. And if you've been following the AI space lately, you probably felt that shift in the air. We're moving beyond simple chatbots, and into an era of autonomous AI agents, digital teammates that can actually do things across different software systems. But this transition isn't easy. Right now, integrating these agents is messy, requiring custom code for every single tool and connection. It's a major pain point for developers, and it's slowing down innovation. So, this complexity is precisely why today's episode is so vital. We're going to be talking about something called the Model Context Protocol, or MCP, a new standard that is currently the subject of a massive buzz across the industry. And before we jump in, a quick housekeeping note. If you're watching this live right now or our chat is open, of course, you need to be subscribed to participate, but it's live. So please drop your questions and comments there throughout the stream. We'll address as many as we can. If you're catching this on demand later, please do us a favor, hit that like button, subscribe to the channel, and drop your thoughts in the comment sections below. Your engagement helps us bring more content like this to you. We want today's conversation to be interactive, so here's a quick question for the live chat right now. How familiar were you with this MCP? Drop your answers in the chat. Are you using it already? You have no idea what it's about and why that's why you're here. We'll check back on those in a bit. And I am thrilled to dive deep into this topic with my special guest today, Darius Liktorius, currently a tech executive and easily one of the most brilliant tech professionals I know. We're going to explore what the MCP really is, tackle some of the common questions people are asking about managing these autonomous systems safely, and even discuss some fascinating real world use cases. And Darius, let me bring you here. Welcome to the show. It's fantastic to have you here. Thanks so much for joining us on this stream today.
You're welcome. Thank you for having me. I hope everyone's well.
Yeah.
Looking forward to it.
All right. So let me bring a presentation, because before we jump into, why don't we discuss some basics, Darius? Because let's see. I know that some people may have experience and may have been hearing about AI and agents and context and all of that, but in case someone is new, there is the screen. Are you able to see the screen? Yes, right?
Yes, I can see it.
So yeah, let's align it on a few basic concepts here. So let's start by an AI agent. What is an AI agent, right?
Yeah. So an AI agent is essentially a piece of software running on a server that is able to take inputs, process those inputs through something known as a large language model, which we'll discuss next. And that large language model then helps that AI agent to essentially respond and take actions on your behalf. So it's one thing to interact. Probably a lot of folks here have messed around with Copilot or ChatGPT, probably is the most common one. And that is not directly an AI agent per se. You're asking, an AI fronted LLM model, a large language model, to basically provide you with with answers to your questions. But an agent specifically is something that goes off and tasks for you. And so in the context of a ChatGPT, you could look at it as the agent in ChatGPT is not the interaction with you and that user interface, but you've probably seen where when you ask it a question, it's going behind the scenes and it's it's basically researching, it's finding websites and it's looking things up and it's cross-referencing things. And if you have the paid versions of these things, they do even more, right? They go in there and they really think harder and they analyze what they've retrieved and determine whether what they retrieved is accurate and correct. And if they need to, they'll do more. So that entire process of interacting and thinking on your behalf, and then presenting those results would be constituted as an AI agent doing that work for you.
So it's actually software. We can say that, right?
It is absolutely software, yes.
It's not a living thing. They're actually
No,
thinking.
no, not yet. No, I'm kidding. Yeah.
So what about these large language models or LLMs?
Sure.
We see that everywhere, right? That acronym is everywhere.
Yes.
Where is it coming from?
So it started out, everyone probably first heard of it as GPT. We had different versions of GPT. And then we had, there's models like Gemini, and there's now, different ones from Grok, AI, XAI, etc. Each one of these large language models are essentially, think of it this way, a large library of data with a massive index over top of it. And that index, just for everyone's knowledge, is typically known as a vector index or a vectorized index. And so what they've done is they've essentially trained these models. In AI, you have a concept of a model and you can train the model. The model is essentially a definition and an index of mathematical vectors that essentially mathematically come back to standards of deviation that determine how far away from the current context that you're interacting with that those particular indexes are. And it then goes and can analyze from there and determine what it is that you're asking it and what it needs to go do. Now, a large language model, there's different sizes of models. You can have a super small model that's trained to do just one thing, add 1 + 1. You can literally have a model do that, simple mathematics, if you wanted to do something like that. You typically would train a custom small model to do something like analyze a specific piece of data, but it's not something that's going to have larger context to basically answer any type of question that you may have. And so that's where a large language model comes in. An LLM has basically been trained on a large corpus of data or a set of data that you don't have direct access to necessarily, but that particular model was trained off of, for example, websites that were publicly accessible, perhaps GitHub public repositories that were otherwise publicly accessible, government data, Wikipedia, other different websites and sources that were publicly generally available for consumption, and perhaps even paid content that particular provider of the large language model, like OpenAI, has actually paid to license the data and has now trained their model using a very substantial set of computers and compute processing, like not in just the millions, but literally the billions of dollars of computational, infrastructure and electricity needed to actually train that model, so that model has all of the vectors that we talked about and has the ability to reference the data and where it exists and where it got the data and be able to interact with you inside of something like ChatGPT.
Wow, that's a very long and geek answer that you gave us about LLM.
I don't know if I can give a shorter one.
Right. I mean, usually there is a short answer like, "Oh, it's the language engine behind an agent," right? That would be the. But this was super geek. It's great for this show. I love it. Thank you. And so, what about context? What are we talking about when we say context? What is it used for? Why do we care about context, right?
Sure.
Especially.
Sure. So the context is essentially at that moment in time when you start interacting with the LLM through a session. The session is your context. So that session window, if you will, maintains context and is able to track what it is that you were asking it and interacting with it on, and essentially build upon that context or that session state of the subject or topic at hand. So you'll probably notice that as you ask GPT or Copilot more and more questions, all of a sudden, 5 minutes later, it's remembering that in your initial question, you had some specifics that you laid out, right? Or as you went on, you added some attributes or properties to your asks that now it's recalling those as it moves forward and further refining those answers for you. So that's what the context is maintaining that state. And I'll just take it a little step further, geek out again. So a large language model, when you're interacting with it, is essentially based on something known as tokens. Tokens are essentially words or segments of words, like a portion of a word up to sometimes 6 or 8 characters or 10 characters, even if the word is longer, that constitute a token. So if you have a really long word, it might be 1.5 tokens in length. So there's a certain number of tokens that can be maintained in context based on a particular large language model. Some of them are very small in terms of their token size. It's only maybe perhaps a few thousand or 4,000 or 8,000 tokens. So it can only maintain up to 4,000 or 8,000 words, for the lack of a better word, in its context for being able to interact with and answer your questions, right? Some of the larger, or some of the more capable models, and the ones that are typically also, paid for, can run into the hundreds of thousands of tokens. And so that your context window, as it's referred to, becomes even wider and broader, and you can maintain even more state. And this becomes really important in really in-depth research, or specifically if you're developing software using a large language model with the help of Copilot or Claude or some of these other tools. You need a larger context window for as your code base becomes larger, in order for that model, that large language model, to understand your code base when you interact with it. More and more context needs to be available to it. And so that's why you would want to use perhaps a larger context window capable model that will obviously cost you more.
Mm-hmm. So. And now that you mentioned tokens, people may see when you go to pricing that sometimes it's displayed by tokens. So you could say, I have 1,000 tokens or whatever the number is, right? So what is that? So that Darius just said what a token is. That's an important concept to include. So with that foundation, Darius, and before we jump into MCP specifically, can you help our attendees understand the following? What do we mean by a protocol in tech? Because this is the MCP is the modern context protocol, but the protocol word in tech means something. What does it mean?
Absolutely. So protocol is essentially, think of it as a language, an agreed upon language and means of communication. So going way back, prior to the internet really becoming too popular, or having direct internet connections over fiber optic cables and cable TV, internet connections and all that, Xfinity, etc. You had bulletin board systems, and people would dial up with modems. And when they would dial up, they had to set up a protocol, a communication protocol between those two modem devices, so that one computer can talk to the other computer and each side could understand. And there were different types of protocols for different types of things. So like if you just wanted to communicate text, the protocol that would be used there would be one type of protocol. But if you wanted to download a large file, for example, and that as the communication happens, just like it does over any network, you can have interruptions to those communications, right? So basically you ended up with a different protocol for transferring files that could handle error correction. So if there was perhaps a blip in the communication, it could retry without failing the entire download of the file. And the same thing happens over the internet today. So HTTP is a protocol. It's a standard for communicating over what is transport control protocol underneath that, which is part of the TCP/IP stack. So essentially, they're all layers of protocols of communications of a language of understanding between two parties. And in this case, it's a language of understanding between us and the large language model.
There you go. Amazing. All right. So let's jump into it. What's an MCP and what problem is it trying to solve?
Okay, so we learned about large language models, we learned about contexts, and we learned about a protocol, right? So this
Right.
is the model context protocol. And what the model context protocol is solving is creating a standard of communication between essentially a large language model and the chat interface, of course, that's taking place, and other third-party systems, whether it be a database or whether it be some other website or an API of some sort, or whether it's a Git repository or some other piece of software. So what the model context protocol does is standardize the way that all of these different components can communicate with the large language model so that it can be orchestrated and run as what we touched upon originally, which was an AI agent.
Amazing. I love this picture because it makes I'm a visual person, so when I see
Sure.
pictures, it helps me a lot understand the concept. Amazing. I love this. And so, how does the MCP architecture work at a high level, at least?
At a high level, there's a couple different aspects to the architecture, and I don't know if you grabbed any additional things or if you want me to just speak to this particular slide. I'm happy to do that. But basically, the architecture has, at the highest level, you have a client. Well, actually, you have like a host. So an MCP host would be an application, right? And that application is what goes ahead and actually hosts, from our point of view, a client for interacting with an MCP server. And then you have some MCP server out there. It can be on a network, it could be over the internet, or it could be a local MCP server using a local standard. And if we want to go into more in-depth understanding of what those are, on a server that's remote from us, it's typically handled over an HTTP transport layer. If it's local on your machine, there's different software components can expose an MCP server using something called the standard IO or STDIO input output stream that we all have. Essentially think of it as the console, that you have inside of a command prompt in a shell on a computer. That's standard IO. And so you can have a local MCP server that's able to communicate with other software through that console interface. That's another way to communicate. If it's, again, locally hosted, typically used just by you inside of a piece of software, Visual Studio Code or something else like that. That's one way that you might be able to interact with a local MCP server. But a lot of times they're going to be remote.
Nice. But you're telling people here that they can test this by themselves on their computers.
You can install MCP servers locally on your machine. If you're a software developer, you can create MCP servers that can run locally on your machine and just interact locally in that way, or can be hosted, like I said, over HTTP
Nice.
for remote access.
I see a question from Arewa there. She's asking, does MCP enable greater interoperability between different kinds of large language models when working with multiple agents?
Does it, the first part, I'm sorry, you broke up. What was the first part?
Sorry. Does MCP enable greater interoperability?
Interoperability.
I'm sorry, yeah.
Okay,
it's too small that I can... Yes.
Interoperability with what? I'm sorry?
Between different kinds of large language models when working with multiple agents.
No, I'm not. I guess you could. I've not worked with it in that way. I'm assuming that someone's created an MCP server that could reach out to different large language models. Typically, you select a particular large language model that you want to work with. And then your software, your MCP client, running inside of the MCP host. And we'll just use one example. Take Visual Studio Code if you're developing software and you're using Microsoft's Visual Studio Code. That's the MCP host for all intents and purposes. There's a client inside of it, and it's communicating with an MCP server that's out there. The client is essentially Visual Studio Code's ability to interact with an MCP server, if you want to look at it that way. And then the MCP server itself could be somewhere out on the internet, for example. And one example that I thought of to discuss in this particular presentation is Azure DevOps, for example. Azure DevOps, where you can host your Git repositories and all of your work items for developing software, has an MCP server, and there's an actual capability then within Visual Studio Code to communicate over MCP, to that server.
That's amazing. So is MCP more like an API, a plugin, an integration pattern?
It is a standard.
Different?
It's a standard it's a standard protocol that allows software to interact using that standard, so that you can build one MCP server one time, and then any software that understands how to interact with MCP can interact with that MCP server. Now, typically the software that's doing that interaction is not you or I interacting directly with the MCP server, right? We are asking the AI agent that we have selected inside of the software like Visual Studio Code. And in that case, the agent is running through, for example, GitHub Copilot, and GitHub Copilot selects a particular large language model, or you select one explicitly, and you are now asking that large language model to interact with that particular MCP server by way of the Visual Studio Code. So Visual Studio Code can basically understand what commands or what information that MCP server is capable of presenting or interacting with. And now it will, in this case, Visual Studio Code will essentially be the broker of information between the large language model and, in this case, Azure DevOps, for example.
I love it. The broker. Love this. Yeah. All right. I see a question from David Cobb in the chat, and he can also answer it, I suspect. Yes. Hi, David. He's asking, hi, Darius, what tools shall data developers learn to rebrand themselves as context engineers?
Context engineers. Well, just because we're discussing model context protocol doesn't mean that as a developer, we need to create our own MCP servers. However, we can. So we might have our own software that we've created that has an API, for example, and we might want that API to be accessible through an MCP standard server protocol, right? And so that's perhaps one area where, as a developer, you might go ahead and front your API in that way. But I believe that the broader question there and the broader use case would be is how do we as developers interact with MCP servers, right? And I would say that is very use case specific, but I would encourage you to simply search online for the different types of technologies that you use in your development shop or your development house in your organization. Examples might be GitHub, right? It might be Azure DevOps. It might be, for example, what we do professionally in my place of employment is we have something known as Datadog. Datadog is a large security and event information management platform. So all of our logs, all of our metrics, everything goes into Datadog. And what we can do is we can actually interact with the Datadog MCP server directly inside of Visual Studio Code. We can ask it to evaluate a particular performance issue or a high error or failure rate that took place on Tuesday at 2:45 p.m., right? And we can actually ask it to then evaluate our code and actually try to determine where the problem in our code might be that caused that issue, that incident. And it actually is pretty impeccably good at doing so.
Isn't that amazing?
It can save you hours of time trying to figure out where your problems are. Yes.
That's the great use of AI.
Exactly.
Right there.
Yeah.
Love it. So any risks introduced by these MCPs that we should be aware of?
Absolutely. So whenever you interact with an MCP server, you're inadvertently going to be sharing information that you directly type into your chat window, right, with then a large language model. You are also needing to be aware of what you're granting access to the MCP. So for example, if you're sitting in Visual Studio Code and you are actually evaluating, you're connected with a code base on your end and you're interacting with an MCP server, you need to be mindful of the fact that it's possible that your code could be shared with that MCP server, or parts of your code could be shared with that MCP server, not necessarily. So in the example previously of Datadog will never see my code. It will simply interact with the large language model to understand the time of day and so forth and so on. And then it's up to the large language model, which will have access to both the Datadog information and parts of my code, or at least a snapshot of my code in a vectorized form, which we can talk about another day. But basically, there's a chance that you could expose parts of your code or a interpretation of your code to the large language model. So yes, it's important to always evaluate what MCPs you're working with, what types of data they receive as inputs, and take that into consideration.
Nice. What do you say if we go to the last question before we jump into the demo? Because the demo is the best part of it. So not every AI setup requires an MCP, correct?
That's right. Yeah.
How should teams decide whether they need one?
So the way I see MCP servers is as an extension of your core functionality of what it is that you're using an LLM for. So in the core functionality of using an LLM in terms of software development, you're asking it to generate code for you, right? And so in that particular example, I would say that you are very defined in what you're doing with the LLM. If you feel like you need now to interact or automate things with a background running AI agent that you can have execute things while you go check your tea kettle or get coffee or have lunch, there may be things that you can offload to the agent and not just the building of the software or the code, right? So an example like I gave with the Datadog, for example, you might want it to run in the background evaluating what caused the delay or the error rates inside of your code, right? In the case of the Azure DevOps interaction, you may want it to build software off of existing work items inside of Azure DevOps. And so that's, again, a different type of interaction beyond just interacting with your code base with your prompt. So you're adding extensibility to that agent and what you're working on in terms of whether it's Copilot or whether it's Cursor or Claude. You're asking it to essentially be able to do more and pull more context. Remember that. Pull more context in from someplace else beyond just your chat window and the immediate thing that you're working on.
This is a great reality check, because not everything needs more architecture just because it's new or interesting, because it's very popular right now. You may need it or not, but it's there. And we have open source. We have also from vendors. You get to decide what you want to use and what you want to invest, because that is open source doesn't mean that it's cheap. I mean, you really need knowledgeable people to handle that, and you may need to configure it more, et cetera, et cetera. And then we have the vendor solutions that can be great for you. So that's important. All right, so do we jump into the demo? Any questions, any thoughts from the chat while we prepare the demo? How are we doing? Are you excited to try this?
Let me share my screen really quickly here. Where am I here? Share screen.
Should we do an entire session about this? Not a live stream, but a session to go in more depth. Maybe we can use some Power BI and reports, MCP servers.
Let me share my
Any other tools?
Yeah. So what I have in front of me right now that I was able to throw together quickly was something inside of Visual Studio Code. But yeah, that is a good example that Power BI, for example, has MCP server as well. And you can interact with that MCP server to interact with your Power BI environment and and allow it to do things for you from Power BI desktop, for example. This is a website that I just wanted to point everyone to as a resource. It's modelcontextprotocol.io, which is where Cecilia got this particular screenshot and some of the additional information that we've been discussing here. And so this is a great place for you to come and take a look at the architecture, what servers are and what clients are, and essentially understand the standard of MCP if you want to learn more about it. It's not a requirement, but it's something that's probably good for you to read through. So let me minimize this really quickly, and let me pull up here Visual Studio Code. And what we have here essentially is I installed Visual Studio Code. I created an empty folder. I connected Visual Studio Code to Copilot, to GitHub Copilot, where I have a paid license. So you would need a GitHub Copilot license to do this. Otherwise, Visual Studio Code is free. And here you see that we have different modes. There's an ask mode, an edit mode, a plan mode. These are all different ways to interact with the actual Copilot. One of those additional modes is the agent mode, where you ask it to go off and do things for you in the background. If you're asking questions, you're interacting with the large language model. If you go into agent mode, you are actually asking it to interact not only with the large language model, but with any additional MCP servers that you have configured. So how do you configure what MCP servers you want to interact with? Over here, you have this .vs code folder, which is a reserved folder name for Visual Studio for holding your options and properties and configuration settings. And if you create an mcp.json file, this file will contain a list of inputs that can be made available to then send to a particular configuration for one or more servers that you might have defined on your machine. So I'm going to go ahead here and just quickly stop this, because by default it's not started. So what is this? This is basically, I copied and pasted this from the actual, unfortunately it closed on me, but let me go to Azure DevOps MCP server, and we will find here a page, if I scroll down, on GitHub from Microsoft. So this is Microsoft's repository for Azure DevOps MCP. And you'll notice here that basically there's a lot of information, there's files, there's examples, there's documentation and such.
Amazing.
And ultimately there's an installation and getting started guide, and that will guide you through creating this MCP JSON file. And this is just an overview of different types of questions that you can ask into your agent prompt and to Copilot that will then interact with your particular Azure DevOps repositories and projects and all of that. So that's what I did. I went ahead and I actually created this mcp.json file. I literally copied and pasted what you see over here in the installation and getting started guide. Right here, I literally clicked copy and I copied. Let me make this a little bit bigger for everyone's benefit.
I was going to ask. Thank you.
There you go. I went ahead and I copied this particular configuration into that file, into the MCP JSON file. And then because there's an actual input, the input will actually be prompted the very first time that I attempt to interact with this MCP. It will actually ask me for my Azure DevOps organization name, which you can see right here. This is a temporary one that I created for demonstration purposes only. So here you'll see that there's a little handy start link right next to this definition of this Azure DevOps MCP server. So I'm going to go ahead and start it, and right away it's running. And what this is doing is it's actually running an MCP client on my local machine that then knows how to interact with Azure DevOps. So that's essentially how this works. And if we look at this actual set of it says that there's 80 tools that are available here. And if I click down here at the very bottom, and I've tried to make this pretty big, but I'll try to, in the interest of not making this too large, down at the very bottom right here, you will see this configure tools link. I'm going to click on that for just a second, and I wanted to show you how you can see. I'm going to collapse all these. These are different tools that Visual Studio has available to it. It has the built-in tools, for interacting with the agent and the web and all this stuff and executing things in a command prompt from GitHub Copilot. And it has this ADO, set of tools, which I've defined. I've defined that I want ADO to basically work off of standard IO locally on the inside of my machine. A requirement for this to work was to install something called Node.js. And from here, basically, it interacts with this particular resource, which is essentially the Azure DevOps MCP service. And from there, like I said, it prompted me for the organization. So if I look here under ADO, you'll see that there's a whole set of definitions of different commands that you can invoke to this MCP server. So for example, core list projects will retrieve a list of projects in your Azure DevOps organization. There's interactions with pipelines, there's interactions with repositories, and then work items, which you'll see test plans as well, wikis. Here's work items coming down here. So I have my, work assigned, basically list your different iterations for your work items and all of that. So there's a lot in here. There's, like I said, there's 80 apparently, and I think they continue to add to it. And so nice. That is helpful to understand, right? So if I come in here and I say, list Azure DevOps projects.
That's our prompt with the agent, correct?
This is our prompt with the agent. So we're in agent mode. We're using this LLM model. Specifically was selected automatically. I can go ahead and actually pick auto if I want to interact with it that way, but we'll just leave the model that was selected. Actually, let me go back in here to the documentation really quickly and just give you an example. List my ADO projects. Let me just do this, right? So let me copy and paste this here, although I think this would have just worked if I spelled it all out anyway. So list my ADO projects. So the very first time that I ran a command, it actually prompted me to authenticate with my Azure DevOps, account, my Microsoft Online account. And you'll see that it's creating a to-do, command, and it's basically querying Azure DevOps to retrieve your projects. So it ran the core list projects command, and it's now asking me, it's about to run it. Do you want me to allow this command to be run? I could click allow with every single time, or I can say I want to allow inside this session or this workspace, or always allow. So I'll just go ahead and say I'll always allow it to do this. And so now it's going to go ahead and run, and you'll see that it's launching, and it had to re-authenticate with my account. I'm already logged into my account in the browser, so it didn't prompt me for a password. And it now says, okay, you from this point forward, I have a token, and an authentication token, and I can interact with your projects. And you'll see here that it said that it queried ADO and retrieved the projects. There's 2 projects here that are available for it, right? So there's an MCP server demo and something left over from when I did a Fabric demo some time ago. So here's an example of it was able to interact with Azure DevOps and retrieve those projects. If I come and I log into Azure DevOps right now, you'll see, hold on a second. Helps if your computer will let you type this. Let me see. I'm on a remote desktop machine that I just set up for this demo. So just a minute. Here we go. All right, why didn't it actually, here, there's my link, MCP server demo. Hold on a second. Here we go. I just wanted to come back in here and just show you those 2 projects that I have in my organization. You'll see that they match. All right, so if I come out to my organization, here are my 2 projects that you saw inside of the actual MCP interaction. So here's an example of being able to interact with that particular MCP server, right?
So this agent is interacting with your DevOps.
Sorry, go ahead.
I'm sorry. Can you hear me?
That's right.
Okay. So yes, this agent is interacting with your DevOps and is listing the projects that you have there. That's amazing. I mean,
That is
it's an
correct.
example,
Yep,
right?
that is correct. So that is an example, yes.
Wow.
So from here,
other,
from here, yeah, sorry, go ahead.
No, it's okay. It's okay. This is amazing. I love it.
So what and you just cut me off whenever you need to. I know we spent a good amount of time on the pre-demo section. I'm happy to still go through this a little bit further if you want, though. Here, hold on a second. I had asked ChatGPT to create a bunch of. So let me sign into this really quickly. Hold on a second. I thought I was already signed in, and I don't know why it's not coming up. Hold on a second. Where did I have my actual, let me come into my history and pull this up really quick.
So to the people that are there in the chat, what are other examples that you can think where you can use this, or where are you excited to use this with?
So while we're waiting for those questions to come in, yes. Here's a prompt that I put into ChatGPT. I said, I want you to create a set of Azure DevOps features with full descriptions and acceptance criteria for a console application, which displays a hello world message and then accepts input from the user from a list of 5 menu items. If the user selects one of the items, the console application simply writes the contents of that item to the screen. So I have these features. And what I was going to do was to just quickly create these particular features in the backlog on Azure DevOps. And then we were going to ask basically the LLM to build the application based on the features.
Nice.
So if you want to do that, I'm happy to do that.
Okay.
So let me come in here.
Can we do it in 5 minutes?
I possibly.
Let's see.
Possibly.
No pressure.
No pressure, yeah. Let's go ahead and create this really quick. I actually don't have yeah. All right, let me do this. I'm gonna put these up side by side. So let me do that right here. And right here. And let's take this particular title right here. We'll take this description. We'll take this acceptance criteria. We'll save it, and we'll go back to our work items. We'll create another one here really quickly. There's not many of them. Oops, hold on a second. There we go. It sure created a lot of features for me. I should have told it to create 2 features that handles everything. Let's get this over. All right.
Damian, hello,
All
Damian
right.
Montero. He says, I want to see an MCP that reaches out to external API instead of just a local exe. Can that be done?
Yeah, I would assume you could create an MCP server that could potentially do that. But ultimately, what you typically see is you'll have an MCP server interface that's following the MCP protocol standard, fronting a particular API that you specifically created. And so there are websites out there. The name right now is escaping me, but there's websites that essentially have an MCP marketplace, for the lack of a better word. And you're basically able to essentially plug into those various MCPs. So there are, for example, MCP servers that front various APIs that, others that might, front you to a particular CRM and so forth and so on. All right, so we've got this here. Let me just put this particular example here inside of the description. I just want to expand a little bit here in terms of the context so that it actually uses that for our information. All right, so we've got 5 features. Let's go into our into our Azure DevOps, into our Visual Studio Code here and ask it to look at the features. List Azure DevOps features. I just want to make sure that it can see them first. And I'm going to close this MCP JSON file really quick.
I
think it's thinking a bit too much.
Thinking. It says it's thinking. The agent.
It is thinking through what it is that it needs to do. Nah, it did not. It did not like that. Let me come back in here to the documentation really quickly. All right, so list. I would have thought that would have been sufficient. List my work items. I mean, they're not all necessarily assigned. I just want to. I guess we should have probably told it that we want to go into a particular project, right? So list all work items for project. What was my project name here? Let's come back here. MCP server demo. Okay. So what this is basically doing is the agent is taking that particular question or prompt rather, and it's analyzing how it should essentially interact with that prompt and answer your question. So as you can see, it did finally this time pick up work item types to go ahead and actually see. And again, it's got to ask me if I want to allow this command to run, because I never ran this command yet here inside of this Visual Studio Code. And so forth. So, well, it thinks that there's none assigned to me. So apparently it's going to insist that they have to actually be assigned to me. And so I could do that quickly, but let me just come in here really quick, update this. I'll just do a couple of these for now. Well, you know what? I got a faster way to do this. Let's get realistic with this here. Let me go this way. And I am going to edit all of these. Why isn't it letting me edit multiple selections? Do this at work all the time. I forgot to sacrifice to the demo gods. So
it's live.
All right. It is live. That's the problem. Yeah. So anyway, let's just close this out really quickly here. I think for the interest of time, we may not get as far as we would like in the demonstration. However, I think that the point that we're trying to make here as far as allowing our agent to interact with a particular LLM, and I'm just going to switch this to auto just to make sure that it's not thinking too much.
Damian in the chat is saying
allow it to run faster.
Live demos are always funner to watch. I agree completely.
They definitely are. Yeah, they're even more fun to give. It's always exciting.
Yeah.
All right. Still thinks there's 0 work items. We're going from bad to worse. List work items. List ADO work items assigned to me in project. What was the project? This is the pop quiz.
MCP server demo?
Yeah, MCP server demo. Let me go back to the model that I had. I typically wouldn't expect this to happen, but let's see why it's not. Of course,
so
when you need it to work, it's
what we can do is we can do a follow-up session and not the live stream, and we dive into this. We geek around and we may spend like 2 hours on this.
That sounds great.
Right?
That's perfectly. Sounds like a great idea. Yes, we'll do that.
Because this is a lot of fun. I mean, I want to keep looking at this.
Yeah, and we can. We'll definitely we'll get all the kinks worked out of this one for
Yes,
for the
Damien
demo.
is saying, yes, please. Yes, let's do this. Maybe we can do it in person,
Get the
but
kinks out. Get the kinks out.
we will do one live for sure. So stay tuned. We will be posting this. You can follow us on LinkedIn. We are both on LinkedIn under our names there. And we will be posting when this will be done. So this has been great, Darius. We talked about why context matters for AI, what MCPs, model context protocols, are, and where they make sense as teams move from simple prompts to real AI agents working with real systems. So, Darius, before we wrap, if you had any, if you had to give one piece of advice to teams starting to explore MCPs, what would you want them to keep in mind?
I would say that to just explore with it, right? Especially on a personal basis, if you're not working inside of your organization or your employer, where there might be security concerns. Of course, if there are, you should obviously check with your network information security team, et cetera, and so forth, and put that disclaimer out there. But on a personal note, there's nothing really preventing you from trying to work with those MCPs from your respective applications. So more and more applications are adding support for interacting with AI and LLMs, and also the MCP capabilities as well. You gave one. Power BI is a great example as well. So there's numerous applications out there that are adding that capability. So just explore and see if it's available for your application, and then what MCPs you can interact with.
I love that answer. And also it's fun. Let's explore.
Absolutely.
So yeah, if you found this conversation useful, make sure that you like the video, subscribe to the channel, and share it with someone building or experimenting with AI. It really helps the channel. And for everyone watching, where do you see context being the biggest challenge in your AI solutions today? Drop your thoughts in the comments. Keep dropping them. We'd love to continue the conversation. Thanks for joining us on Cecilia's Tech Corner. And thanks, Darius, a lot. This was a lot of fun.
You're welcome.
And see everyone in the next episode.